Hello and welcome to the AI Research Roundup. I am Alex, and today is May 10th, 2025. We are looking at a paper from Hugging Face's trending list, published 4 days ago, titled Unified Multimodal Chain of Thought Reward Model Through Reinforcement Fine-Tuning. This research paper introduces UNIFIEDREWARD-THINK. It tackles the problem that current multimodal reward models, or RMs, which evaluate AI outputs like images and text against human preferences, often provide shallow feedback. The core idea is using explicit long chain of thought, or CoT reasoning, essentially showing detailed, step-by-step thinking to generate more accurate and reliable reward signals for complex visual tasks. Alright, so this first figure gives a really nice overview of the comparison results. Part A presents a qualitative case study. You can see how UNIFIEDREWARD-THINK uses that detailed chain of thought reasoning to compare two images, breaking down its decision based on criteria, like semantic consistency, aesthetics, and authenticity. Then, Part B shows quantitative comparison results as bar charts. These clearly demonstrate that their full model, especially after its final training stage, using Group Relative Policy Optimization, or GRPO. A technique where the model is specifically trained on examples it initially misjudged, helping it explore better reasoning paths, consistently outperforms other approaches. Alright, moving on, this diagram lays out their three-stage training pipeline. Stage 1 is cold start, where the model learns the basic structure of chain of thought reasoning from a small dataset. Next, in rejection sampling, it practices on lots of diverse data, and only the good reasoning examples are kept for further refinement. Finally, the third stage uses Group Relative Policy Optimization. Here, the model undergoes reinforcement fine-tuning, which is a process where it learns by trial and error, getting feedback on its answers, focusing specifically on examples it previously got wrong to improve its detailed thinking. Okay, so building on how the model is trained, this next figure provides a great visual example of its chain of thought reasoning in action, specifically for video generation. We see the model comparing two videos of a robot dog, based on a shared caption. It then explains its preference by breaking down the evaluation into semantic consistency. Basically, how well the video's content matches the given text description. Then temporal coherence, which looks at how smoothly and logically the video flows. And finally, authenticity, or how realistic the visuals are. This detailed step-by-step assessment really highlights the kind of interpretable feedback the model can provide. So following that video generation example, this next figure presents more qualitative cases. These are specific, illustrative examples, this time focusing on how the model applies its chain of thought reward reasoning to image and video understanding. For instance, with an image of a tennis player, the model evaluates two different textual descriptions. It breaks down its assessment based on semantic accuracy, which is how well the description matches the image, then correctness or factual accuracy, and finally, clarity. This detailed, step-by-step thinking allows it to robustly determine which description is superior, showcasing its ability to provide nuanced feedback. So, we have seen how this approach uses detailed chain of thought reasoning for robust evaluations. A key takeaway is that this multi-stage training helps multimodal reward models, or RMs. AI judges for other AIs, handling images and text, generate much more reliable feedback. This training even improves the reward model's ability to give good direct answers. And, as the authors confirmed, each training stage is vital. This really advances how we align AI with human preferences. Thanks for tuning in to the AI Research Roundup. I am Alex.